Okay, we're going to be looking at graphing exponential functions. Tomorrow in class you'll see that I'm just going to ask you to graph 4 exponentials. So this is really a review of things that we've done in integrated algebra. We did graph exponential equations back then, talked about exponential growth and exponential decay, and the basic form of an exponential function looks like what we have here, y equals constant to the x. Well, honestly, that's an equation. A function would look more like f of x equals some constant inside the parentheses, and we're raising that constant to a variable exponent. Okay, so the whole idea of a variable being in the exponent now. Often we've seen variables but not in exponents before, except when we dealt with exponential functions. We didn't do too much with them in freshman year, though. We just graphed them. We know that if the constant is a number that's larger than 1, then that'll represent exponential growth. If that number is between 0 and 1, it will represent exponential decay. A minus sign out here would mean something different. That would actually mean a reflection over the x-axis. So before we get to the graphing, I just want to show you something quickly on the Inspire. And I'm going to make a couple of quick graphs here. The first one I'll graph is, I think we'll graph, we'll put a fraction in there. So I'm going to graph 3/4 to the x power. And you'll see a nice graph of it there. Like all our exponential graphs, it goes to the point 0, 1. That shouldn't be a surprise if you've done this before. Well, now I'm going to graph a second function on the same graph, graphing line. And now I'm going to graph the reciprocal of that 3/4. So I'm going to actually graph 4 divided by 3, not question mark 3. And we'll raise that to the x power as well. And so I think you can see clearly from this graph what happens when we take the reciprocal of that constant. We end up reflecting that black curve over the y-axis to give us the pink curve. So they are reciprocal. They have been reflected over the y-axis, these two. They're not inverses of each other. Inverses, we know, would have reflected over yet a different line. Inverses reflect over that green line, and certainly we don't have a reflection over the green line, but we do see that reflection over the x-axis. Okay, so let's take a look at what will be required on the graph tomorrow. Again, to point out that anytime you're asked to do a formal graph, it's all about being accurate and being precise and being thorough. So that's going to mean labeling all your x-axes. You do have this note here that says plan ahead for the axis labels. Well, I'd like you to first notice that you are asked to graph over a specific domain here. Because you're asked to graph over the specific domain between -3 and 3, that means you can let your x-axis values go from -3 to 3. And that's really all you should cover if you're graphing over the domain -3 to 3. You may include the -3, we'll have a closed dot there. You may include the 3, we'll have a closed dot there. But we don't need the 4 here, we don't need the -4 there. Technically it would not be correct to do so. Okay, we need a table of values calculator here. And I'm going to turn off that side screen. Okay, so let's just leave our calculator right there, and I'll go to a new graph page, and I'm going to add that first graph 2 to the x power. And there's my curve. Control T will give me the table, and I'm going to need to go up to -3, so let me get up there and see what's up there. Okay, at -3 I got a 0.125. Let me check that off so it'll stay out there. A 0.125. And a 0.25 is next, a 0.5 is next, a 1, 0, 1, no surprise there, a 2, a 2, 4, a 3, 9, and those are actually in the table there. So there's your x value, there's your 2 to the x. And now the second graph, 1/2 to the x power, so I'll make a new graph page. I don't want to put too much on one graph. This is 1/2 to the x power. And so I graph that. You can see the reflection over the y-axis. We'll do a control, escape that, do a control T to get the table. And again, we're going to need to scroll up to see what's happening at -3. And you can see at -3, whoops, I went too high. At -3, and you may be able to figure these out on your own. This keeps jumping on me. -3, I'm actually going to be looking at a 9 there. So -3, I got a 9. think I'll change colors here. -2, I've got a 4. -1, I've got a 2, 0, 1, no surprise, 1.5, 0.25, and 0.125. And you can see the relationship between these two tables. When I take that reciprocal of my constant there, I end up with a reversal of the numbers that you see centered around 0. So now that I've got the picture, or the table is completely filled out, I can very carefully and thoroughly draw. Please be sure you're labeling your x-axis and your y-axis. We'll begin with, I'll call this my green function first. So I'll go to -3 and a 0.125. You can't know exactly where that is, just come close enough. -2, a -1, 0.501, that's got to be there. 2, 4, 1, 2, 3, 4, and 3, 4, 5, 6, 7, 8, 9. Now, again, technically, if you're supposed to graph in between -3 and 3 on the x-axis, that graph should not extend forever in both directions. This says you're not allowed to go beyond -3 on the left. You're not allowed to go beyond 3 on the right. So now we'll graph the other equation on here, the 1/2 to the x power, -3, 9. -2 down at 4, and what you'll notice is that you see a perfect reflection over the y-axis, and again with the warnings about not going beyond -3 and 3 if that's the domain instruction that you were given. A little bit tough with this pen to follow the curve, but there we go. Since you have two functions on the same graph, we're not going to leave it that way. We're not going to walk away from this without labeling each one. You have to do that. We want to know which is which. We can't leave it to the grader to guess. 1/2 to the x power, and looks like we've got everything we need at this point. So that's your complete graph, and you'll get some practice doing that. Since this video is so short, 7 minutes, let me just show you a couple of things. I want to talk about some transformations for a minute. We've seen transformations already this year. We saw transformations with parabolas, where we would start with y equals x squared, and then we would start adding and subtracting things inside that. We've seen transformations with lines. We've seen transformations with absolute value functions, where in both of these cases we could watch the vertex to tell us what happened as far as translations, as far as shifting left, shifting right, horizontal shifts, vertical shifts up and down, stretches and shrinks. Well, we really have the same kind of thing going on with our exponential equations. I start with this basic 3 to the x here, and that's the heavy blue one. And if you look at the black one, what happened with the black one is I took that basic 3 to the x and I added 2 on the end. So that 0.01 got shifted up 2, and that shouldn't surprise you. That should be an expected result. If I put a minus in front of the equation, or in front of the function, what that does is have the effect of reflecting it over the x-axis. We've seen that before. So all of the points that were above by a certain distance are now below by a certain distance. So the red curve represents your reflection over the x-axis. If you look at this green curve here, 3 to the x minus 6, well, remember your horizontal shifts left and right, the signs work the opposite way that you thought they should. When you had pluses, the whole function shifted to the left. When you had minuses, the whole function shifted to the right. So that stays consistent with what we've already done. And if you, again, you watch that 0.01, you see where it goes. It has shifted 6 units to the right. And that's -6 is up there with the x and the exponent.